Hello students. Welcome to IMS Gate Academy. Students, I am really excited to share you the most conceptual problems on reinforced cement concrete. I hope you are doing good. As it is a Sunday, students, you should be able to attend the sessions on the Gate Score Booster on the topic RCC. Today, I will be covering you the most conceptual problems on reinforced cement concrete. See students, first of all, let me tell you why do you want to study the reinforced cement concrete. See students, in the GATE exam, the weightage for reinforced cement concrete is 4 marks. But the most conceptual problems can be expected from the limit state design or single reinforced section or from the pre-stressed concrete. So these are the things which I will be focusing more on. Now my dear students, welcome to IMS Gate Academy. Here is the Telegram group. In the Telegram group, if you want to access the classroom notes or the YouTube classroom notes or any updates in the YouTube platform, apart from the YouTube platform activities, if you want to do the daily quizzes, we will be posting the quizzes in the Telegram group where you can answer them and test yourself. So these are the advantages of the Telegram group, students. If you have not joined in the Telegram group, the link is given in the description. Please click on the link and join the Telegram group session. Now my dear students, we at IMS Gate Academy proudly to announce you that we are offering 800 plus hours of live as well as offline gate coaching. We are providing the offline gate coaching at Jayanagar, at Bangalore, and also we are providing the offline gate coaching at Vijayawada, at Bench Circle. Now my dear students, wherever you go, you have to practice yourself to make yourself ready for the exam. As part of this, we are providing an excellent study material. For every subject, we will be providing the subject material. Along with that, we are providing the exercise book which contains level 1, level 2, level 3 questions, and here you can test yourself based on your preparation. My dear students, let me tell you the most important thing, the GQB, which we call Gate Question Booklet. We will be providing Gate Question Booklet for the past 30 years with the video solutions and with the key pointers. So my dear students, when you are inching towards the GATE exam, preparation like revision strategy is very important. For that, these key pointers will help you a lot. Now my dear students, the most and the important aspect when you have completed your preparation is testing yourself. So you have to attempt the test series. In test series, we are providing 130 plus test series students. That is chapter test, advanced level test, multiple subject test, or why not all India mock test series, which is the exact replica how you write in the GATE exam. And all India mock test series contains 12 test series. These will be very fruitful for you before the GATE exam to practice. Now my dear students, we at IMS Gate Academy rate the student success as the highest priority. As part of this, we are providing one-to-one My Plan sessions where there will be one-to-one mentorship, and this can be provided through the My Plan session where the student weakness can be converted into a strength by discussing, by having a detailed discussion on his weakness and how to overcome the weakness to make it as a strength. Apart from this, we are also providing the doubt solving portal where your doubt can be explained within 24 hours of time and you will be ready. Now my dear students, let me tell you the most important thing. Today here I am here to discuss. Now quickly I will go into the subject. Now students, see here we have RCC. Now my dear students, what do you mean by RCC here is, RCC stands for Reinforced Cement Concrete. What do you mean by RCC? Reinforced Cement Concrete. My dear students, this is a subject where you expect a lot of questions in the exam point of view as well as in the interview point of view. Now my dear students, what do you mean by reinforce according to the Oxford Dictionary? Reinforce according to the Oxford Dictionary is nothing but make it stronger. Okay, reinforce according to the Oxford Dictionary, what is the meaning of reinforce? Reinforce is nothing but the make it stronger. Now the common question everyone will ask me here is, why do people use cement and concrete? Why not other materials? People will try to tell that concrete is strong in compression, steel is strong in tension. But let me tell you the fact, the actual reason is the coefficient of thermal expansion of steel is approximately equal to the coefficient of thermal expansion of concrete. My dear students, am I audible or not? Can you please write in the chat box? So here, the reason here is the coefficient of thermal expansion of steel is approximately equal to the coefficient of thermal expansion of concrete. That is the reason, main reason why they are using steel and concrete in RCC. And let me tell you what is the basic difference between analysis and design. And let me tell you what is the basic difference between analysis and design. See here, my dear students, what do you mean by analysis is finding the shear force, finding the bending moment, all this calculation part will come under analysis. Design is something like dimensions. If you are designing a room, what is the length of the room, what is the width of the room, what is the height of the room. So the dimensions is nothing but design. Now let us go into the limit state method. We have one method called limit state method. What is the one we have? Limit state method. My dear students, they can ask you why limit state method is most appreciated. You can ask me why the limit state method is most appreciated or how it overcome the working stress method. Now see students, let me tell you in a layman words. What is limit state means? It is the ultimate stage. Limit state method is defined as it is the ultimate stage. Limit state method is the ultimate stage. It is the ultimate stage at which the structure is, it is the ultimate stage at which the structure is, unfit for use. At which the structure is unfit for use. So this is the definition. So how the structure can fail? One is unfit means the structure can collapse, okay, or the structure can become unserviceable. Yes or no? So see students, what is limit state method is? Limit state method is the ultimate stage at which the structure is unfit for use. Now how the structure is unfit means either the structure can collapse or either the structure can become unfit. Now let me tell you what is the actual meaning of the limit state in terms of the actual definition. Limit state is the method of, or you can say it is the method of designing a structure based on statistical concept of safety and the probability of failure. What students? If you are talking about safety, it is a method of designing a structure for safety. It uses the principles of statistics. For safety, it uses the principles of statistics. And for failure, where it is going to fail, you are not aware. So for failure, it will be seeing probability. So let me tell you, my dear students, what is limit state method? Limit state method is a method of designing a structure based on statistical concept of safety and probability of failure. Now my dear students, one of your friend might ask me, sir, why limit state method is highly appreciated? Now let me tell you students, suppose if I talk about design load, design load is taken as load into partial safety factor. Are you getting me students? If you consider design load is taken as load into partial safety factor. So here you can say limit state method is designed for higher loads. What sir? Limit state method is designed for higher loads. Similarly, see students, if you talk about the design strength, strength upon partial safety factor, here partial safety factor will be always greater than 1. So you will be designed for lesser strength. So my dear students, Why limit state method is highly appreciated? Because it is designed for higher loads and it is designed for lesser strength. So this ensure, these two things ensures double safety, my dear students. These two ensures double safety. You have to understand this, students. Are you getting me? Why limit state method ensures is appreciated? Why limit state method is appreciated when compared to working stress method is, it is designed for higher loads, and even though it can carry more strength, they will be selling that it carries less strength to ensure. Good evening, Srujana. Good evening. So this limit state method ensures double safety. That is the reason LSM method is most appreciated. Now, if I talk about the partial safety factor for concrete, if I talk about the factor of safety or partial safety factor of concrete, remember, see students, concrete has a factor of safety 1.5. What is the partial safety factor for concrete? It is 1.5. And remember, the partial safety factor for steel, the partial safety factor for steel is 1.15. Okay. So remember here, students, the partial safety factor for concrete is 1.5 and the partial safety factor for steel is 1.15. Now you can ask me why concrete has having more factor of safety when compared to the steel. See here, students, concrete is manufactured in the laboratory. That is the reason if you want to find out the strength of concrete, you will be taking 3 cubes. Yes or no, sir? You will be taking 3 cubes. But whereas if I talk about the steel, steel is manufactured in a industry. Steel is manufactured where, sir? Steel is manufactured in the industry. So here what I would like to tell you is, what is the reason for concrete to have more factor of safety is, the reason is simple, Amma. You can say quality control. Quality control is the major reason for the factor of safety for concrete to be more when compared to the factor of safety for steel. Okay, I hope you are clear with this. Okay, now let me tell you another important point, and the most important point, sir. See, students, you should have a basic idea. Sir, even though it is a theory part, what I have seen from last 5 years in the GATE exam is the assumptions in LSM method, we are expecting a question. So the first assumptions you can write here, students. The assumptions in LSM method. So when I talk about the assumptions in LSM method, students, the first assumption is sections which remain in plane, sections which remain in plane before bending, sections which remain in plane, sections which remain in plane before bending, sections which remain in plane before bending, remain in the same plane, remain in the same plane even after bending, remain in the same plane even after bending. So what does this assumption say, students? So what does this assumption says? Let me tell you. Sections which remain in plane before bending remain in the same plane after bending. See, students, this assumption says that strain varies linearly. This assumption says that strain varies linearly, and this assumption is known as what, sir? Bernoulli's assumption. So this is the assumption where you feel that the strain varies linearly. Clear, students? Now the most important second assumption we have is the maximum strain in concrete. The maximum strain, are you following, students? Very good, very good. The maximum strain in concrete is 0.0035. So this was a direct question asked in GATE 23. What is the maximum strain in concrete? Suppose see students, if the strain in concrete is more than maximum strain, obviously concrete will fail. Obviously concrete will be failing. And remember, on what basis you are telling that concrete will fail is, this is based on principal strain theory. This is based on maximum principal, you can write here, maximum principal strain theory. So here you should know, understand this, sir. What I would like to tell you is, the second assumption is the maximum strain in concrete is 0.0035, and if the strain exceeds this maximum strain value, then obviously there will be a failure. Very good, Sai Srujana. And it is based on maximum principal strain theory. Now let me tell you the stress strain curve graph, the stress strain curve for concrete. The stress strain curve for concrete. How the stress strain curve for concrete will be there, students? If you see, they can ask you, the stress strain curve for concrete is rectangular parabolic. How, sir? It is rectangular parabolic. Now see, what is the value here is 0.002. You have to remember this. And the maximum value, if I consider this as maximum value, 0.0035. And the value here is 0.45 FCK. Okay, these are very important, students. Now let me tell you, students, if they ask you what is the stress strain curve for concrete, the stress strain curve for concrete is rectangular parabolic. What, sir? The stress strain curve for concrete is rectangular. The stress strain curve for concrete is rectangular parabolic. You can say that the stress strain curve for concrete is rectangular parabolic. Now let me tell you here, it need not be a rectangular parabolic. It can be any shape, sir. If this shape need not be a parabola, what I am drawing here, it can be any shape, but there is a clause, it should satisfy the test results. If the test results are satisfied, then it can be any shape. For now, how you got 0.45 FCK is, actually see students, FCK is known as characteristic strength. Now FCK is dropped to 0.67 FCK due to the shape effect. Actually initially it should be FCK, but why it was reduced to 0.67 FCK? Because of the shape effect. Because in concrete, every time it need not be a parabola. In construction, you make it in different shapes. That is the reason, due to slenderness ratio or due to the shape effect, the concrete strength has been reduced to 0. Or reduced at 33%. Now see students, if I talk about the design strength, what is design strength? Concrete strength is 0.67 FCK, and the factor of safety is how much, sir? For concrete is 1.5. So this value will be equal to 0.446 FCK. That's how we have taken, how this value came 0.44 FCK. Just to explain you, I have given this detailed explanation. Now let me tell you the stress strain curve for, now let me tell you the stress. Now see student, if I talk about the stress strain curve for, okay, here if you see here, see students, this is the yield point. This we take it as Fe 250, that is mild steel, and here you can write it as HYSD bar. What is HYSD bar, sir? High yield strength deformed bars. Now see students, If you consider here, this is 0.87 Fy. How you got this 0.87 Fy? Because see students, here if I talk about the design strength, strength upon the partial safety factor for steel. What is the partial safety factor for steel, sir? The partial safety factor for steel is 1.15. So here you can write it as 0.87 Fy. So that's how this formula 0.87 Fy came. Now see students, if you see here, you cannot plot where is the lower yielding point. Yielding means change in behavior. For this, what I will draw is, I will drop a offset here, which is at a value of 0.2 percentile, which will be equal to 0.02. And what is this value, sir? See, students, the slope of this. Now see, students, if you consider here, it will be 0.87 Fy only. The slope will be, the slope of stress strain diagram is nothing but Young's modulus. So you know Young's modulus is equal to stress upon strain. Stress is 0.87 Fy by strain. So strain can be written as 0.87. Strain can be written as 0.87 Fy upon Es. So my dear students, the distance from here to here, if you consider, this value is taken as 0.87 Fy by Es. Am I correct or wrong, my dear students? Very good. So here what will be the strain value is, if I consider the strain value from here to here, the maximum strain in steel is 0.87 Fy by Es plus 0.02. And based on this problem, there was a GATE 2023 question. So see students, let me tell you what IS code says is, if the strain has been yielded to the maximum strain value, or use not strain, I should say steel. If the steel has yielded to the maximum strain value, then that steel is most economically utilized. Very important point, students. Again, I am telling you, if the steel has been yielded to the maximum strain value, then the steel has been most economically utilized. Very, very important point. So if you see the stress strain curve for steel, 0.87 Fy by Es plus 0.002. This is the stress strain curve for what, sir? For the steel. I hope you are clear. Very good students. Now see students, let me tell you single reinforced section. Now let me tell you single reinforced section. What is a singly reinforced section? A beam which is reinforced on tension side is nothing but singly reinforced section. A beam which is reinforced on tension side. A beam which is reinforced on tension side is known as singly reinforced section. Now see students, let me tell you, based on the amount of steel provided, based on one second, student. Based on the amount of steel provided, 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 we have three sections, students. One is the balanced section, and other one we have is the under reinforced section, and third one we have is the over reinforced section. So now see students, let me tell you what do you mean by balanced section. Remember students, in practically balanced section never exists. It is impossible to have a balanced section practically. But why do you want to find out balanced section? Sir, actually to find the depth of neutral axis, balanced section is utilized. So what are the conditions for balanced section means? The maximum stresses in steel and concrete or the stresses in steel and concrete reaches the maximum value simultaneously. What he is trying to say, sir? The stresses in steel and concrete reaches the maximum value at same time, which is impossible to exist practically. But why you are assuming balanced section, sir? To find the depth of the neutral axis, we assume the section to be balanced. So what are the conditions for balanced section is? The condition for balanced section is nothing but we assume x, okay, AST is equal to area of steel required is equal to limiting area of steel. Similarly, depth of neutral axis is equal to limiting depth of neutral axis. And another important thing is balanced failure fail primarily due to primary compression, because usually when you see the quantity wise, concrete is very high compared to steel. That is the reason, because there can be more chances for the concrete to fail in balanced section. That is the reason we take the failure is by primary compression. Now what do you mean by under reinforced? Let me tell you, sir, what do you mean by under reinforced is the amount of steel provided will be less than, see, suppose if you want to provide some X amount of steel, but you will be providing the amount of steel less than that X. So amount of steel provided to balance the section, or amount of steel provided is less than the amount of steel required to balance. So that is under reinforced. So whenever you are providing less amount of steel, obviously the failure will be in steel. Now my dear students, steel is a ductile material. As it is a ductile material, it shows a clear sign of failure, that I am going to fail, or take me to the hospital, like that. You can see spalling of the concrete and right. So that is a kind of indication that steel is going to fail. So when it is going to fail, you will take a repair or a rehabilitation technique to overcome it. That is the reason most of the practical sections are under reinforced, as it shows a sign of failure. Now what are the conditions for a section to be under reinforced? What are the conditions for a section to be under reinforced is XU should be less than XU max, XU should be less than limiting depth of neutral axis. Similarly, AST, area of steel, should be less than limiting area of steel, area of steel should be less than limiting area of steel. And remember, my dear students, how the failure, you are telling that failure is obviously in steel. So steel fails mainly by primary tension. So under reinforced, the failure is by primary tension. Primary tension. Now see, let me tell you what do you mean by over reinforced section. As I told you, see students, in the name itself we are having over reinforced. If suppose if you required X amount of steel, they will be providing more amount of steel. So the amount of steel provided will be the more than the amount of steel required to balance the section. Sir, there are two materials X and Y. If you are increasing X means obviously Y is decreasing, right? So the failure will be in the concrete. But let me tell you the most important thing, concrete is a brittle material, students. As concrete is a brittle material, the failure will be sudden. If you take a glass and if you drop the glass, glass will break immediately, right? So concrete is such a kind of material which is brittle, which breaks. So that is the reason most of the sections should be under reinforced and over reinforced sections should be avoided. So what are the conditions? Practically, remember students, all the over reinforced sections should be avoided as the failure is sudden. You should remember that. Now what are the conditions for over reinforced section is, you can say XU is greater than XU max, or you can say AST is greater than AST limiting, or AST is greater than AST limiting. And similarly, failure is by, obviously failure will be in steel is more, so failure is in concrete. So you can write it as primary compression. You can write it as primary compression. Now just go through this slide for 1 minute, students. Okay, very good, students. Now let me go in details of the most important thing, that is the design part. Now when I talk about the design part, students, see, this is very important, students. Okay, I'll tell you the major things about the single reinforced section. Now see, students, we have taken a rectangular beam here and we are trying to draw the neutral axis here. Okay. I'm drawing the strain diagram, students. Okay, this is the strain diagram, students. So as I told you already, strain varies linearly. Now see, students, if I talk about the stress diagram, as I told you, the stress varies. You can say the stress is varying to a very rectangular parabolic, right? Now see, students, let me tell you here. See here, what I would like to tell you is a beam which is reinforced with singly reinforced, a beam which is reinforced with steel in the bottom means on the tension side. Now as you know, what is the strain value at, what is the maximum value at the strain here, sir? The maximum value of the strain is given by 0.87 Fy by Es plus 0.002. This diagram is very important, students. What I am trying to say, the maximum value of the strain in steel, you can say the maximum value of strain in steel. Similarly, the maximum value of strain in concrete is 0.0035. Okay, here we can say this is the depth of the neutral axis, which you can write it as XU. Okay, now see, students, here I can write this as width of the section B, and here I can write this as effective depth D. Okay, and remember, students, this will be considered as overall depth D. This will be considered as overall depth D. Now here see, students, here I would like to tell you, here you know already up to parabola, if you see the strain values, the strain value will be equal to 0.002. Okay, see, students, what will be the stress here? It will be equal to 0.446 FCK. Okay, now let me tell you, here we have the tension force, which is 0.87 Fy AST. And we will have, what is this value by interpolation? I am just telling you directly, sir, because it's we want to do some more problems. So I will take this value as 4 by 7 XU, and this value is 3 by 7 XU. Okay, now whatever I am writing here, sir, these are very important. Remember, see, students, to find what is the compression, where does this compression force acts? Okay, let first tell me this is compression force. Now see, students, here I would like to tell you what is the compression force here is. What is the compression force? Compression force here is equal to 0.36 FCK into B into XU. What is compression force, sir? Compression force is equal to 0.36 FCK into B into XU. Agree? Similarly, see, students, here, what is tension force? What is tension force here is, tension force is equal to 0.87 Fy into AST. This is 0.87 Fy into AST. This is called tension force, and this is the compression force. Remember, my dear students, to find the depth of neutral axis, So XU can be written as 0.87 FYAST, 0.87 FYAST upon 0.36 FCK B. So what is XU here? XU is nothing but the depth of neutral axis. So just go through this slide, sir. This slide is also very important. I'll give you 1 minute. Now see, very good students. Now let me tell you here, we have the another important formula. Now see students, here they can ask you for FE 250 grade, for FE 415 grade, this table you have to remember students, for FE 500 grade, okay, for FE 250, FE 500 and FE, remember see students, this table is important, XU max by D values. If you consider FE 250, XU max by D value is how much, sir? 0.53, and for FE 415, 0.48, for and for FE 400, 500, 0.46. Similarly, see students, if I talk about MU limit or limiting moment of resistance, if I talk about limiting moment of resistance, here what is the value, sir? Here this will be equal to 0.149 FCK BD square. Here this will be equal to 0.138 FCK BD square, and this will be equal to 0.133 FCK BD square. So see students, these are the maximum values of XU max by D values and limiting moment of resistance, which are very important. Are you getting me? Another important thing, let me tell you students, XU max by D is given by the formula 0.0035 upon 0.87 Fy by Es plus 0.0055. And for your information students, this is a very, very important question. What is the question here is, the always XU max by D depends upon, XU max by D depends only on the grade of steel only. Okay, because it depends on grade of steel. What is the Fy students? Fy is nothing but the yield strength of the steel. And what is Es here? Es is nothing but the Young's modulus of steel, which is equal to 2.1 into 10 power 5 Newton per mm square. Okay. 2.5 into 2.1 into 10 power 5 Newton per mm square. Very good, very good. Now see students, we have minimum area, minimum percentage of steel is given by the formula AST by BD is equal to 0.85 by Fy. Sir, the minimum percentage of tension reinforcement You can write the minimum percentage of tension reinforcement is given by the formula AST by BD is equal to 0.85. And similarly, see students, we have another important formula is the maximum tension reinforcement is the maximum. Students, are you following? Can you please respond in the chat box? The maximum tension reinforcement is nothing but 4% of gross area. See students, what is the difference between gross area and effective area means? In case of gross area, we write it as B into capital D, sir. Okay, you write it as 0.04 into capital BD. Sir, this is very important, my dear students. When I talk about the gross area, you should able to understand that here overall depth is considered. For effective area, small d is only considered. I hope these concepts will help you to solve the problems much easier way. Now quickly we will go into the problem, students. We have a beautiful question, students. This is a beautiful question, Sai Srujna. I will be appreciating you if you can do this problem. A singly reinforced concrete beam of width 300 mm and effective depth 400 mm is to be designed using M25 concrete. For the beam to be under reinforced, what is the maximum number of 16 mm dia bars? So this is a beautiful question, my dear students. Just give a try for this question. This is previous year only, but a beautiful question, sir. Now see students, here if I talk about this, she is asking the beam is to be under reinforced. For a beam to be under reinforced, first question here is, for a beam to be under reinforced, for a beam to be under reinforced, for a beam to be under reinforced, see students, AST should be less than or equal to, for a beam to be under reinforced, AST should be less than or equal to AST limiting. Yes or no? For a beam to be under reinforced, the area of steel required should be less than or equal to limiting area of steel. Now see students, first we will calculate AST limiting. Okay. So to find out the AST limiting, I told you compression force 0.36 FCK B into, see my dear students, when XU is replaced by XU max, AST should be replaced by limiting area of steel, and similarly if you are calculating the moment also, moment should be replaced by limiting moment of resistance. Ravi, good evening Ravi. Are you following, Ravi? Okay. So here 0.36 FCK B into XU is equal to 0.87 Fy into AST. So here what I would like to tell you is XU can be written as, so here if I put XU max, my dear students, here AST will be coming as AST limiting. Now my dear students, the equation intention is to find out the limiting area of steel. So how do we find the limiting area of steel is, AST limiting can be taken as 0.36 FCK into B into XU max upon 0.87 Fy. Now my dear students, if you see what is the grade of the steel, it is 25, width is 300, effective depth is 400, and for a beam to be under reinforced, the maximum number of 16 bars. And the grade of steel is what, sir? Fe 500. Very good. Now see, students. So here if I substitute 0.36, okay, FCK is how much, sir? What is the grade of the concrete? It is 25. So 0.36 into 25. Width of the section is 300. And remember, my dear students, how to calculate XU max. Sir, XU max is depends upon the grade of the steel. So here the grade of the steel is Fe 500. So you have to substitute it as 0.46D. So 0.46 into effective depth is taken as 400 upon 0.87 into Fy is how much, sir? 500. So if you calculate now by solving this equation, you will get the limiting value as some around 1142 mm square. Am I correct or wrong? 1142.0 or 6 mm square you will get. Okay, 1142.6 or 1142 mm square. So see, students, he is asking what is the maximum number of 16 mm dia bars. Sir, there is a very tricky question here. N into pi by 4 into 16 square is equal to limiting area of steel is how much, sir? 1142. So this is what, my dear students, always remember, this is nothing but the limiting area of steel. This is always the limiting area of steel. So here if I calculate N will be taken as around 5.68. You will be getting N value how much, sir? N value will be equal to 5.68. Very good, Surujana. You will get 1142.06. Okay, 1142.06. If you calculate the value of N value will be taken as 5.68. Now he is asking what is the maximum number of bars. Sir, most of the students will answer it as 6. If you have written 6, that means you are providing the area of steel more than the limiting area of steel. Then the section itself will be changed. It will not be under reinforced. It will be over reinforced. The beautiful part of this question is the area of the steel provided should be less than AST limiting. So the answer can be 1, 2, 3, 4, 5. But he has used in the sentence, in the problem, he has asked that maximum number of steel bars. So the maximum number means obviously there will be one answer, that is 5. So remember, students, please don't write it as 6. If you write 6 bars, so what will happen? The section itself will be changed. The section will become as over reinforced, which is absolutely wrong. So most of the people, when they are solving this previous year gate question, until here they have written 5.68 and they have written to 6, which is a small mistake which caused them a costly mistake, because they will lose 2 marks and the answer will be 5. So very good, Srujana, very good. So here the option is 5. So option C is the correct answer. Very good, Srujana. Now please solve this question, Amma. Please solve this question. Please solve that question, students. Now see students, I have given you enough time. Here he has asked in the problem, what is the minimum percentage of steel? Now my dear students, I told you already, the minimum percentage of steel is given by the formula AST by BD. AST by BD is equal to 0.85 upon Fy. Okay. Now see students, I can write here minimum percentage of area AST is equal to 0.85 divided by Fy into B into D. So this is the formula for AST. Agree? Now see students, what is the grade of the steel here? What is the grade of the steel here? Grade of steel is nothing but Fe415. Okay. And what is the width of the section, sir? Width of the section is 250 and 400. So you can write here, you can just simplify 0.85 upon 415 into 215 into, effective width is 250 and effective depth is 400. Okay, see students, if you solve this, you will get a value of 205 mm square. Now see students, he has asked in the problem, another problem is, what is the maximum tension reinforcement? What, my dear students, what is the maximum tension reinforcement? If they ask you what is the maximum tension reinforcement, here the maximum, very good, 204.8, absolute. You can take it as 205 mm. Very good answer, Srujana. So maximum tension reinforcement is nothing but 4% of gross area. Remember, see students, in this problem, they have told you to assume effective depth as overall depth. He has given in the first statement. Sir, effective depth of 450 mm is reinforced with 4. As per the, means here you can assume the effective depth is the overall depth. Okay. If they have not given you the overall depth. So maximum tension reinforcement will be equal to 0.04 into 250 into 400. Okay, so you can write here 0.04 into 250 into 400. Okay. Now this value will be equal to how much, sir? 250 into 4 is how much? 1000. 1000 into 4, 4000. So the answer here is 4000 mm square. So maximum tension reinforcement is 4000 mm square and minimum tension reinforcement is 205 mm square. So the option here is 205 and 4000. So the option B is the correct answer. I hope this solution is clear for you. Now see students, if you talk about the key points here is, the minimum tension reinforcement is given by the formula AST by BD is equal to 0.85 by Fy and maximum tension reinforcement is 4% of gross area. These are the key takeaways. Very good, Srujana, very good. Now this is another interesting problem. Please solve this problem. I will give you 2 minutes of time. Just solve this problem, sir. Okay students, I have given you enough time. Now let me tell you, sir, I have given you enough time. Okay, let me tell you, what do you mean by characteristic strength, students? See, characteristic strength, first of all, you should know what is characteristic strength, okay, before solving this problem. Now see, when anyone asks you what do you mean by characteristic strength, means it is the strength at which 95% of the test results are expected to pass. Nirmal Nikhil, maximum 4250. Maximum 4000. Nirmal Nikhil, check it once, amma. You might get 4000 because see, here what you have done, I just want to see. Sir, 0.04 into 250 into 400. You can write it as 4 by 100. 400 is 4 times. 4 into 250 is 1000. 1000 into 4 is 4000 mm square. Please check Nirmal Nikhil. Okay, now see, what is characteristic strength means? It is the strength at which 95% of the test results are expected to pass. It is the strength at which, characteristic strength is the strength at which 95% of the, it is the strength at which 95% of the test results are, it is the strength at which 95% of the test results are expected to pass. Or you can say, students, where not more than 5% of the test results are expected to fail. So this is the basic definition of characteristic strength. Okay. Okay, that's what I told you, Nirmal Nikhil. Okay, that's a very good question. I told you when I am explaining you Nirmal Nikhil, what I am trying to say here is, there if they have not, actually in the bracket in the actual question of GATE exam, they have given assume effective depth as overall depth. Are you getting me? So if you take extra 25 mm, that is a good thing. You have followed the procedure, but in the question they have given you assume effective depth as overall depth. That is the reason I told you in the point also. Okay, very good question, Nirmal. Very good question, Nirmal. I have told you that point also. Now see, students, here first of all they have given you different specimens. First try to find out the mean of the strength. First I will find out the mean, sir. So what is the mean means? Are you agree, Nirmal Nikhil? So what is the mean here is, mean can be taken as 4 into 23 plus 2 into 28. So there are 4 cubes of 23 strength. There are 2 cubes of 28 strength. Plus there are 5 cubes of 22.5 strength. So 5 into 22.5 plus 5 into 31 plus 4 into 29. Very good, Nikhil. Very good, Nikhil. 4 into 29. So here how many concrete specimens are there? Anyhow he has given here 20. So divided by 20. So what is the value you will get, students? After dividing with 20, what will be the mean? Sir, what will be the mean? Can anyone tell me? Sir, what will be the mean here? The mean value will be equal to 26.75 MPa. The mean value is equal to how much, sir? 26.75 MPa. Now, my dear students, you have to calculate the standard deviation. You have to calculate S, which is known as the standard deviation. How do you calculate standard deviation, sir? Standard deviation is given by the formula. Standard deviation is given by the formula sigma I is equal to 1 to n f minus u whole square upon n minus 1 square root. Okay. Now, just for your information, I will show you some things here for 1 or 2 things. Okay, how you have to do is 4 into 23 minus 26.575, sorry, 26.75 minus 26.75 plus, you have to do for whole square plus so on. Last I will do 4 into 29 minus 26.75 divided by whole square divided by 20 minus 1. Sir, you have to do how I will repeat it. 4 into 23 minus 26.75. Similarly, 2 into 28 minus 26.75. 5 into 22.5 minus 26.5. You have to summate all these and you have to take the square root upon the square root is for 20 minus 1 also. You can write here. The square root is for entire term. After calculating here, see students, you will get a value of how much, sir? You will get a value of standard deviation. Standard deviation is, how much you will get, students? Standard deviation value will be equal to 3.697 MPa. What is the value you will get after calculation? You will get a value of 3.697 MPa. What is the value you got, students? You got a value of 3.697. Now what he is asking here, calculate, see, if mu is the, here he has given one thing, if mu is the mean and sigma is the standard deviation, what is the value of strength greater than less than mu minus 3 sigma? So he is asking what is the strength. Name the number of specimens, cubical specimens with the strength less than mu minus 3 sigma. What is mu? Mu is 26.75 minus 3 into 3.697. On substituting this, what is the value you will get, students? Can anyone tell me? You will get a value of 15.485 MPa. What you will get, sir? You will get a value of 15.485 MPa, which is equal to 15.485 Newton per mm square. So here what I would like to tell you, name the cubic specimens which are having a strength less than 15.485. If you see here, there is no cubical specimen which is less than 20 itself. So the number of cubical specimens whichever is less than 15.485 is 0. So the answer here is 0. So the number of specimens are, there are no specimens which are having a strength less than 15.485 MPa. I hope this is clear for you. So what is the key takeaway from this problem is, characteristic strength is defined as the strength at which 95% of the test results are expected to fail. Here first you have to calculate the mean, and standard deviation is given by the formula sigma I is equal to 1 individual strength minus the mean value whole square into the number of specimens divided by n minus 1. If you do in this way, you can calculate the sigma standard deviation, and using that formulas just plug in that values and you will get the answer. I hope this solution is clear for you. Let me go into the next solution. This is a very good question, sir. Please solve this question, students. Now see students, I have given you enough time. The question here is simple. For M25 concrete with the creep coefficient of 1.5, what is the long-term modulus of elasticity? Now see students, actually in the stress strain curve, if we draw the tangent at the origin or at the beginning, it is called initial tangent. If you draw normal nickel 111 point, no. Okay, you might have taken in a different way. Okay, normal nickel small change, I will tell you. You are almost near to the answer, but I think you have taken short-term modulus as 5700 root FCK, but the present code says it is 5000 root FCK. Okay, if you draw the tangent, very good try Nirmal Nikhil. If you draw the tangent at the origin, at the beginning of the curve, we call initial tangent modulus. If we draw a point and a tangent at any point on the curve, it is called tangent modulus. If we join any 2 points, then it is called secant modulus. But here what they are asking is short-term modulus of elasticity. Sir Nirmal Nikhil, you have tried the correct only, but now usually the present code says that the short-term modulus of elasticity. If you talk about the short-term modulus of elasticity, Nirmal Nikhil, it is given by the formula 5000 root FCKM. The present formula, if you have taken 5700 root FCK, you might get that answer. Here it is equal to how much, sir? 5000 root FCK. So if I talk here 5000 root FCK, you can write what is the grade of concrete, sir? The grade of concrete is nothing but 25. So 5000 into root 25, you will get a value of 25,000 Newton per mm square. What is the value you will get, my dear students? You will get a value of 25,000 Newton per mm square. So this is the short-term modulus of elasticity. Now, my dear students, if I talk about the long-term modulus of elasticity, if I talk about the long-term modulus of elasticity, if I talk about the long-term modulus of elasticity, here if I talk about the long-term modulus of elasticity, see students, here long-term modulus of elasticity, EL is given as short-term modulus of elasticity upon 1 plus theta. Remember, my dear students, what do you mean by theta? Anyone, can you tell me, sir, here? Theta is known as creep coefficient. What do you mean by creep coefficient? It is nothing but elastic creep by ultimate creep. So theta is nothing but a creep coefficient. But see students, here creep coefficient they have given as 1.5. So long-term modulus of elasticity is equal to short-term modulus is 25,000 into 1. Theta is how much, sir? 1.5. So 1 plus 1.5 is 2.5. If you solve this, you will get a value of 10,000 MPa. So or you can write 10,000 Newton per mm square. Is this clear, my dear students? So theta is called creep coefficient. Okay, here we have the answer. Very good Ajay Kumar, very good. So here what is the answer for long-term modulus of elasticity is, long-term modulus of elasticity is given by the formula short-term modulus of elasticity upon 1 plus theta. So the answer here is 10,000 MPa. So what are the key takeaways from this problem is the short-term modulus of elasticity is equal to 5000 root FCK, where FCK is the characteristic strength of the concrete, and long-term modulus of elasticity is given by the formula short-term modulus upon 1 plus theta, where theta is nothing but the creep coefficient. What do you mean by creep is, it is nothing but the long-term deflection under constant loads. That is the definition of creep. I hope this solution is clear for you. Let us go into the next problem. This is a very interesting problem, students. I will be more happy if anyone solve this question, and I will give you 2 minutes of time. Very good answer, Nirmal. Very good answer. Very good answer, Nirmal. Very good answer, Nirmal. Nikhil. Sir, I have taken enough time. Okay, sir, is it creep coefficient is creep strain by elastic strain? Ultimate creep by elastic. Yes, Nirmal. Sir, is it creep coefficient is creep strain upon elastic strain? So actually, Nirmal, what is creep coefficient? It is defined as the ratio of ultimate creep upon elastic strain or elastic creep, or you can write creep strain by elastic strain. Okay, you can write that, Nikhil. Nirmal, Nikhil. Okay, very good answer, Nikhil. I really appreciate for you this answer. Now, but let me tell you what is asking according to this question. Sir, have you followed this or not? You can check, Nikhil. According to the concept of limit state design, the probability of failure of a structure. Sir, see, according to the limit state design, according to the limit state method, if I take here, there can be two chances. There can be various chances for failure of structure. Yes or no? So, the first failure can be if the load exceeds, design load. Okay. What, sir, am I correct or wrong? The first thing is, actually every time the load, whatever you are doing, that if the load exceeds the design load, this can be the first reason for failure. Second thing, if the strength is less than the required strength, if the strength is lesser than the required strength, and the third one is, sir, here strength required will be more or strength provided is more in the first case. In the second case, load is not more than design load, but strength is less than the design strength. And the third one is, the above two things can fail, load exceeding the value and also strength is less than the required strength. So, how to find out the probability of structure? Sir, I told you what is design load, Amma. What is design load? It is the load at which 95% of the test results are, or it is the load at which 95% of the tests or 95% case it satisfies. So, the failure percentage is how much, sir? Only 5%. So, this condition failure is how much, sir? 0.05, or this condition also the failure is 0.05, and here also this condition is also, both will be 0.05. Now, let us see how do we calculate the probability of two events. You know the probability how you will calculate now, students. So, here the probability of one is load exceeding but strength is okay. Load exceeding, strength is okay is given by the formula 0.05 into strength is okay means 0.95. Next case, sir, here load failure I am writing for you. Here it is load fail. Here I will write it as strength fail 0.95 into 0.05. This is what, my dear students? This is nothing but the strength fail. And the next case will be, sir, P of, okay, next case will be what, sir? Both will fail. So, you can write as plus 0.05 into 0.05. Here 0.05 into 0.05 indicates that this is load failure and also strength is also failing. Load and strength both are failing here. Load and strength both are failing. If you add all this, you will get a value of 0.0975. How much value you will get, students? You will get a value of 0.0975. So the answer here, if you talk about percentile, the percentile means into 100. So you can write it as 9.75. You can remember this value also, student, but the procedure I have told you. I hope this solution is clear for you. Now please solve this question, Amma. I'll give you 1 minute of time. I have given you enough time in the previous problems, so I'll give you only 1 minute time for this problem. Okay. Now see, I have given you enough time, students. Here the question is, if the characteristic strength of the concrete is defined as the strength below which not more than 50% of the test results are expected to fail, then the expression for FCK in terms of target mean strength would be. Now see, students, let me tell you the graph here. The graph here says that if a graph is drawn between number of cubes and the characteristic strength, okay, here we take it as 5%. FCK. Here if I take it as target mean strength. Remember, see students, target mean strength, if it is 5%, general case I am telling you students, target mean strength is given by the formula FCK plus a constant which is equal to 1.65s. So this is the standard formula where it is defined as 5% of the test results are expected to fail. So here this is the 5%, but here he is telling 50%, this is the standard deviation, but here he is telling 50% is here. So he is telling 50% of the test results are expected to fail. So what happens? The target mean strength and the strength both will coincide. So here when you see here, very good Nikhil, here what happens is, here you should understand that standard deviation, if you see here, the standard deviation will be equal to 0. If you see in this case, what will be the standard deviation? The standard deviation value will be equal to 0. So if I substitute the value of standard deviation as 0, you can write here target mean strength is equal to characteristic strength of concrete. So this is the final answer you have. Because here see students, why FM will be equal to FCK? Because here the key point is, he himself has told that in the problem, characteristic strength is the strength at which 50% only are expected to pass. In that case, the standard deviation will be 0. If you substitute standard deviation as 0, then target mean strength and characteristic strength both will be same. I hope this solution is clear for you. Now please solve this problem, students. See students, this is a beautiful question here we have. Please solve this question. I'll give you 2 minutes of time. It's a beautiful question. I want everyone to solve this problem, students. Nikhil, wrong answer. Please check the answer. Now, very good students. See here, let me tell you the concept behind here. You might have studied in strength of materials. What is the effective length means? It is the distance between the points of zero moments you might have studied. But according to RCC students, suppose if you talk about the simply supported beam, if I talk about simply supported beam, the effective depth is taken by two conditions, students. The effective depth is taken by two conditions. What are the two conditions here is, one is L plus D, you can say, okay, one is the effective length plus center to center distance plus D, okay, or you can write, sorry, first case is clear span plus D, let me write you like this, effective span is effective length, you should write effective length. Okay, for a simply supported beam, what is the effective length is, first condition you can write it as clear span plus D or center to center distance between supports. So, see students, out of these two conditions, now let me tell you, out of these two conditions, whichever is smaller will be considered as effective depth, effective length of the span. If you talk about cantilever, sir, here clear span is taken as, for cantilever, if I talk about cantilever, here it is a simply supported beam. So, for cantilever it is taken as how much, sir? Clear span plus D by 2, my dear students. For cantilever it is taken as what, students? For clear span plus D by 2 is the value for cantilever. Now let me read this question. A reinforced concrete beam with effective depth 80 mm is simply supported with the ends at two opposite ends of 230 thick masonry walls, and the center to center distance between is 3.3 meter. Now what is the answer is asking. So let me tell you, Nikhil, please check it now, ma. Suppose if I consider this as a thick masonry wall, and we have a thick masonry wall here, okay, we have here, this is the span, if I talk about the span, okay. Now see students, Nikhil, here they have given you center to center distance is how much, sir? This is 3.3 meter. Now see here, Nikhil, what is the effective depth here is, this is 230 mm, right? So this is also 230 mm. This is also 230 mm. Now if I consider this as clear span can be written as, now how to calculate clear span? Can you tell me, Nikhil? How do you calculate clear span? Clear span can be written as center to center distance minus between the supports minus, here we have half of the thickness of the wall, here also we have half of the thickness of the wall. So you can write center to center minus thickness. So if I talk about the center to center, students, okay, if I talk about the center to center, this value is equal to 3.3 meter minus thickness of the wall is 230 mm. We have to convert into meter, students. So this value will be equal to 0.23 meter. So this value will be equal to 3.07 meter. So this value will be equal to how much, sir? 3.07 meter. But what is 3.07 meter? It is the clear span. Now if I talk about the effective length is what, sir? Effective length is nothing but, or you can say effective span, sir. Effective length or effective span. You can say here 3.07 plus depth is how much? Effective depth is 80 mm given in the problem. Sir, it was given as 0.080. So the total value will be equal to 3.15 meter. Now out of these two, we have center to center as 3.3 and effective span from clear span plus D, we got 3.15. Very good, Nikhil. So the answer here is 3.15 meter. Very good, Nikhil. So the answer here is 3.15. Or if you want me to write in the second, this is the answer is 3.15. I hope this solution is clear for you. Very good, Nikhil. Very good. Now this was a GATE 2023 question, students. So here what he has asked is a singly reinforced concrete beam of section M20 concrete and FE4 and 5, the maximum compressive strain in concretes he is asking. So here see students, let me tell you. As I told you, what is the grade of steel here? The grade of the steel is how much, sir? M20 concrete and FE4 and 5. Now see students, grade of steel is how much? FE415. Anyhow, the maximum compressive strain, you already know. What is the maximum compressive strain? What is the formula, students? The maximum compressive strain in concrete. I told you already. The maximum compressive strain in concrete according to the IS 456. The maximum compressive strain in concrete according to the IS 456. Can anyone tell me what is the value, sir? This value is equal to 0.0035. The maximum compressive strain in concrete is how much, students? This value is equal to 0.0035. Now similarly, what is the maximum strain in steel? So what is the maximum strain in steel, sir? The maximum strain in steel is given by the formula. If you remember, or strain in steel, you need 0.87 Fy by Es plus 0.002. So here what is the grade of the steel, sir? Grade of steel is 415. So you can write here 0.87 into 415 upon, what is the Young's modulus of steel? See students, if they have not given you the Young's modulus of steel, it is a standard value which is equal to 2.1 into 10 power 5 plus 0.002. So what is the value you got? Can anyone tell me, sir, what is the value you will get? Let us do the calculator. So here what is that, sir? 0.87 into 415. What is the value you will get? 361 divided by 2,10,000, right? What is that value? 0.017. So you will get around, if you have written, you will get roughly around the value as 0.0038 roughly. If it is, they have taken 2 into 10 power 5, it will be 0.0038. So what is the answer we have? So the first answer is the correct answer. We will get the first answer, which is 0.0035 and 0.0038. Is this clear, Nikhil and Sai Srujana? Very good, sir. Just try to respond, Amma. Solve this question later. Okay. Now please solve these questions. I'll give you another 2 minutes of time. Please solve this question. I'll give you 2 minutes of time for this problem. Please solve this. Very good, Sai Srujana. Sir, Srujana, very good, 0.0037. You can take according to the option 0.0038. That's what I am telling you. Srujana, if you take 2.1 into 10 power 5, it will be 0.0037. If you have taken 2 into 10 power 5, then it will be 0.0038. Very good, Srujana. Did I answer your question, Srujana? Can you please comment? See students, I have given you enough time, Amma. So what we have to do in this problem? Sir, see the cross section of the reinforcement beam having an effective depth is how much, sir? 500 mm, M35 concrete and FE 550. But remember, see students, the yield strain at steel is given as 0.0044. And if you see, the factor of safety is 1.15, as you know already. But what is asking, what is the limiting depth of the neutral axis? So my dear students, whenever these kind of questions are asked, see students here, this is a T-beam, right? So here when I ask you about T-beam, you should have an idea how the strain is going to vary. And here we have the steel bars. Okay, here they have given one steel bar, right? It is independent of the reinforcement actually strain. So here. Now, if you see the strain diagram, here the value is given as 0.0044 and here the strain value is given as 0.0035. Now, my dear students, if I take here the depth of the neutral axis is, if I take this value as XU max. So, see students, this value is XU max. Anyhow, you know, sir, this is the overall depth, sir. This is the overall depth D. So, this value will be equal to D minus XU max. This value will be equal to D minus XU max. So, from this, here what I could tell you is, from similar triangle concept, XU max upon 0.0035 is equal to D minus XU max upon 0.0044. So, this is, let me tell you, this distance upon this and this distance upon this. Now, see students, you can write here D minus XU max upon XU max is equal to 0.0044 upon 0.0035. But what is the value of D they have given? What is the overall, sir, effective depth is given as 500. So, 500 minus, you can write 500 upon XU max minus 1 is equal to 0.0044 plus 0.0035. Or you can write here 500 by XU max is equal to 500 by XU max is equal to plus, if you take 0.0079 upon 0.0035. So, if you solve this, what is the value you will get, sir? XU max, can Sai Srujana or Nikhil, can you tell me? XU max will be taken as 500 into 0.0035 upon 0.0079. Okay, so if I do this, what is the value of XU max you will get? You will get a value of XU max is equal to some 222.1.52 mm. I hope this is clear for you. Is this clear, students? Very good, Srujana. Very good. Sir, please solve this problem. I will give you 2 minutes of time. Sir, I will give you 2 minutes of time. I want everyone to go through this problem. Very good, Srujana. Now see students, let me tell you two important things. Amma. Actually see, when I talk about losses of pre-stress, when I talk about losses of pre-stressed in concrete, pre-stressed concrete, okay, there are two things, sir. Sir, we have two things basically, pre-tensioning and other one we have is the post-tensioning, okay. Remember students, there are two losses which are specific to post-tensioning. I'll tell you the losses, okay. Now, we have pre-tensioning means the wires are tensioned before casting of concrete is pre-tensioning. What is post-tensioning means the wires are introduced into the ducts. See here, if you talk about the wires, suppose the wires are tensioned and now you will be doing the grouting, or you can say concreting. But if you see in post-tensioning, you will be introducing the steel into the ducts. Okay, you will be introducing the steel into the ducts and the wires are tensioned in this way. Okay, so this is the basic difference between pre-tensioning and post-tensioning. Now, my dear students, what I would like to tell you is there are various losses like elastic shortening of concrete, elastic shortening of concrete. Okay. Now see students, if you ask me what is the elastic shortening of concrete is, this loss, sir, all these are losses. Losses first, loss due to elastic shortening of concrete. The most important point I would like to tell you, when all the wires are tensioned at a time, there is no loss due to elastic shortening in post-tensioning. But in general case, usually it will not happen like that. But if they have mentioned that all the wires are tensioned at a time, then there is no loss due to elastic shortening, you have to write. But usually elastic shortening is observed both in pre-tensioning and post-tensioning, and the loss due to elastic shortening is given by the formula M into FC, where M indicates the modular ratio, and remember, see students, this is an important one because people tend to do this mistake. So what is FC is? FC is nothing but the stress at the level of steel. What is FC, sir? FC is nothing but the stress at the level of the FC is nothing but the stress at the level of the steel. FC is nothing but the stress at the level of steel. So here what I would like to tell you, see students, here FC can be taken as load by area plus you will get M by Z. See, this stress is due to direct load, and if you take about this formula, you can write it as PE square by I, that is M by Z. So you will write it as PE square by I. Now there is another loss also. This is the formula for loss due to elastic shortening. Similarly, you can have shrinkage, loss due to shrinkage of concrete, loss due to shrinkage of concrete. So loss due to shrinkage of concrete is given by the formula Young's modulus into shrinkage strain. What, sir? The loss due to shrinkage of concrete is given by Young's modulus into shrinkage of concrete. Shrinkage loss is observed in pre-tensioning as well as post-tensioning. Now see students, here if you see, similarly creep of concrete, loss due to creep of concrete. See, whatever the losses which I am telling you now, loss due to creep of concrete is given by the formula phi into M into FC. So what is, I told you just now, phi is nothing but creep coefficient, which is ultimate creep upon elastic creep or ultimate creep strain by elastic strain. And we have the next one is relaxation of stress in steel. Sir, whatever the four losses which I have explained you until now, all these losses are observed in pre-tensioning as well as in relaxation of stress in steel. Now all these losses, four losses are observed in both pre-tensioning and post-tensioning. But there are two losses which are specific to post-tensioning. First one we have is the loss due to friction. First loss we have is the loss due to friction. Remember, see students, the loss due to friction is specific to post tensioning. So this loss is only observed in post tensioning. It is given by the formula P naught into mu into alpha plus K into X bar. So here what is mu if they ask you? See students, here mu is nothing but the coefficient of friction. Mu is nothing but the coefficient of friction. And remember, my dear students, what do you mean by alpha here? What do you mean by alpha here is, suppose see students, if you have considered this as a simply supported beam. If I consider this as a simply supported beam, here we have the neutral axis here. So this is how the simply supported beam will be there. So if you see here, this will be theta and here also theta. So here alpha can be taken as theta plus theta. So it is nothing but the cumulative angle in radians. And remember, see students, K is known as wobbling constant. What is K, sir? Wobbling constant. What is wobbling constant means? Usually if you plug in the wire, so if you see, the wire will not be straight like this, but if you find a wire like this, that is called wobbling effect or length effect they call. And we have X bar. X bar is nothing but the length of the span. You can write X bar as length of span. Are you clear, students? So here see students, what I would like to tell you is loss due to friction is observed only in post tensioning. That is P naught into mu alpha plus K into X bar. Similarly, loss due to anchorage slip. Loss due to anchorage slip. Loss due to anchorage slip. Loss due to anchorage slip is also observed with the same formula kind of thing, that is ES Young's modulus into change in length upon original length. So this is the loss due to the anchorage slip. So what is ES, sir? Young's modulus of slip, Young's modulus of steel, delta L is the slip and L is the total length. So these are the important formulas which are coming in the losses of steel, losses of pre-stress. Now let me tell you this question, students. So here what he is asking is, a concrete beam has a span of 15 meter, wide is 150 mm, 350 mm deep, is pre-stressed with a parabolic profile shown in the figure. Now what is the coefficient of friction, sir? Coefficient of friction is given as 0.35 because he has given in the problem. And the wobbling constant K is equal to how much, students? 0.0015. And remember, see students, if you see here, what is the X bar, that is length of this span, X bar length of this span is 15 meter. Okay. Now we have to find out alpha. Okay. Alpha will be finding out if the cable is tensioned from one end. Remember, see students, if the cable is tensioned from both ends, it will be P naught upon 2. If it is tensioned from one end, then it will be P naught only. So see students, here the loss due to friction. Here the loss due to friction. See students, the loss due to friction is given by the formula delta P is equal to P naught into mu alpha plus K into X bar. But see students, he is asking what's a percentage loss. So percentage loss means you can write here delta P upon P naught into 100 is equal to mu alpha plus K into X bar. Okay. So into 100 you can write. Now see students, here mu is 0.35, K is 0.0015, X bar is 15. But what is asking? We have to find out alpha. So see students. Now my dear students, when I talk about parabolic profile, tendon profile, when the parabolic profile, you should know, if I take C, if I consider this as a span or anything, students, if we consider here this, okay, here usually alpha will be, theta, slope or theta is equal to dy by dx can be written as 4h by L. But let me tell you what is h, sir. H, if I consider this as a parabola, this is the height and this is the length of the span. But if you see in this problem, students, the beauty of thing here is the span is, if you consider this as the, here if you see, the span is like this. So here, if you see at the eccentricity is 50 mm, here it is 50 mm, and here it is how much, sir? 75, if I am not wrong. So here, one second. Here it is 70 mm, sorry, 50 and 70. So if you talk here, h will be equal to 50 plus 70 mm, that will be equal to 120 mm. But what is, sir, what is the total length? So you can write here theta is equal to 4h by L. Now what will be alpha, sir? Alpha will be theta plus theta, which is equal to 2 theta, which is equal to 8h by L. So here you can write it as 8 into 120 upon, sir, 15 meter. 15 meter in mm will be how much, sir? 15,000, right? So can anyone tell me what is this value, sir? So 960 divided by 15,000. So this value is equal to how much? 0.064. Are you getting, my dear students? So what is the value, sir? 0.064. So here alpha value is how much? 0.064. But what is asking? The loss of pre-stress due to friction. So delta P by P into 100 can be written as what, my dear students? You can write it as mu into alpha plus k into x bar into 100. So here if you consider here, what is mu? Mu is nothing but 0.35. What is alpha we got, sir? 0.064. Alpha is given as 0.064 plus k is nothing but 0.0015. X bar is nothing but the length of this span into 15. If you consider this into 100. So if you solve these, students, you will get a value of 4.49 percentile. Sir, if they ask you, if they haven't asked you percentile, you should not multiply with 100. So remember, students, what are the key points in this problem is there are two losses. The loss of pre-stress due to friction is observed only in post-tensioning. The loss due to friction is given by the formula P naught into mu alpha plus K into X bar. Here the formula, if it is stressed from only one end, if it is stressed from both ends, P naught will be replaced by P naught by 2. Here mu is the coefficient of friction, alpha is the cumulative angle in radians. So based on the profile of the tendon, the alpha value will be taken, and K bar is the wobbling constant and X bar is the length of the span. Again I am telling you, students, there are four losses. One is the elastic shortening of concrete. When all the wires are tensioned simultaneously, there is no loss due to elastic shortening in post tensioning. Loss due to elastic shortening is given by the formula M into Fc, where M is the modular ratio, Fc is the stress in steel at the level of the concrete. Similarly, my dear students, if I talk about the second case, that is shrinkage, loss due to shrinkage of concrete, that is Young's modulus of steel into strain in, you can say Young's modulus of steel into, or you can say into multiplied by shrinkage strain. Similarly, loss due to creep is given by the formula phi into M into Fc, where phi is the creep coefficient, M is the modular ratio, Fc is the stress in steel at the level of the steel. Relaxation of stress in steel depends upon the manufacturers. It varies from manufacturers to manufacturers of the steel manufacturers. And the losses due to anchorage slip is specific to post tensioning, which is given as ES, Young's modulus of steel into delta L, which is the slip value upon total length of the span. I hope these losses are clear for you. Let us go into the next problem. Please solve this problem, sir. It's a very easy problem. Please start this problem. Good evening, Saurav. I haven't seen you. Okay. I've given you enough time, sir. He is asking in the problem in the reinforced common, what is the nominal cover provided at the bottom of the beam? So, see students, in this problem, first of all, he has asked nominal cover, right? Now, let me tell you what is nominal cover and what is effective cover before solving this problem, students. Okay, let me tell you these two things so that you will be more clear. Now, my dear students, what do you mean? Very good, Nikhil. Very good. What is nominal cover means? Suppose if I taken this as a rectangular section, students. If I consider this as a rectangular section and if I consider this as steel bars and if you have steel bars here, for suppose I am giving students, we have the steel like this, stirrups also, we call this as stirrups. Sir, see here, the distance from the outermost portion of the steel. Sir, what is nominal cover means? You can write here, distance from outermost of the steel. Sir, are you following? What is nominal cover means? The distance from the outermost of the steel, outermost part of the steel, the distance from the outermost part of the steel to the outermost part of the steel to the extreme fiber. The distance from the outermost part of the steel to the extreme fiber is called as nominal cover. Now, similarly, if they ask you what is effective cover, now see students, if I consider this as a section and if I consider this as a steel bar, okay, the distance from the centroid of the steel to the extreme fiber, what is effective cover means? The distance from centroid of steel to extreme fiber, this is known as nominal cover. Are you agree, students? Now let me see this question, students. Now here see, here they have given clearly it is how much, sir? Effective cover is how much? Effective cover is given in the problem as 50. So nominal cover means half of the dia. So dia is how much, sir? 3 bars of 16 mm dia. So dia is 16 by 2. And see students, sir, we have removed the half of the main bar and there is 2-leg dia of 12.5. So we have to remove the value of stirrup also. So nominal cover can be taken as, if I saw here, nominal can be written as 50 minus 16 by 2 minus 12, which is equal to 8, and this will be equal to 12. So you can take it as 30 mm. So the nominal cover can be written as how much, sir? 8 can be written as 30 mm. Very good answer, Nikhil. Okay. Now see students, please solve this problem. I'll give you I'll give you 2 minutes of time, sir. Okay, see students, let me solve this problem. So let me tell you one important thing here, sir. What I would like to tell you is, if you see, we have in column, sir, actually see students, in columns, we have two types, sir. In columns, we have two types. What is that? One is the short column and the other one is the long column. Okay. Now see students, short column fail by crushing and long column will fail by buckling. Now see students, he is asking what is the ultimate load, okay, with zero eccentricity. Are you getting my dear students? They are asking, sir, see, if they are giving, actually if you talk about column we always design for minimum eccentricity. What, sir? If you see the general formula, column is always designed for minimum eccentricity. So if you take about the minimum eccentricity, the formula will be different. So here PU will be equal to 0.4 FCK, that is grade of concrete, into area of concrete, plus 0.67 Fy into area of steel in compression. So this is the formula for ultimate load when you are considering design of a column with minimum eccentricity. But in this problem, students, here is clearly told with zero eccentricity. So with zero eccentricity, if we told this formula, okay, this formula ultimate load can be written as 0.45 FCK into area of the concrete plus you can directly write as 0.75 Fy area of steel in compression. So this is a very, very important formula when we considered zero eccentricity. This is the formula for in case of zero eccentricity. Now see students, how many bars are there main reinforcement? 4 bars of 16 mm dia and total is how much, sir? 250 into 300. So if you talk about area of steel in compression, 4 bar, how much, sir? They have given you how much? They have given as 4 bars of 16 mm dia. So you can write 4 into pi by 4 into 16 square. So this is the area of steel in compression. Similarly, what will be the area of concrete, sir? Area of concrete will be equal to gross area. You can write as gross area minus area of steel in compression. What is gross area? The width of the section of the column is 250 into 400 minus area of steel in compression. What is the area of steel in compression, sir? You can write it as 4 into pi by 4 into 16 square. Now, my dear students, what we have done? They have given you the area of steel in compression, area of concrete also. So, what is the grade of concrete and what is the grade of the steel? Can you tell me in the problem? So, let me write here. Sir, grade of the steel Fy is equal to 415 and what is FCK? FCK is 20 Newton per mm square. Now, if you plug in these values, you will get ultimate load is equal to 918.1 kilonewton. So, see students, I have given you everything, sir. Please see here, students. They have given the area of steel in compression, area of concrete also given, and you know FCK is given as 20, which is 20 Newton per mm square. And what is Fy, sir? The grade of the steel. What is the grade of the steel we have? Which we have is 415. We know the area of concrete. We know the area of steel in compression. If you just plug in all these values, you will get the ultimate load as 918.1 kilonewton. I hope this solution is clear. Please solve this problem, students. I'll give you 2 minutes, 1 minute of time. Please solve that. students, is asking the question. Please read the question here. What is the question here is, as per IS 456, the minimum percentage of tension reinforcement for Fe 500 grade of steel. He has given Fe 500 grade of steel. Now see students, if I talk about the minimum percentage of tension reinforcement, if I talk about the minimum percentage of tension reinforcement, sir, minimum percentage of tension reinforcement is given by the formula AST by BD is equal to 0.85 by F5. So here they are asking percentage, means grade of steel is how much, sir? 500 into 100. So this will be equal to 0.17 percentile. How much, sir? This will be equal to 0.17 percentile. Now let me tell you one important thing, sir. What are the design steps for shear? Now see students, see. Now we have design steps for shear. First one we have to find out is nominal shear stress. What, sir? First the design steps we have is the nominal shear stress. So how do you calculate the nominal shear stress, students? Is the first point I would like to tell you. So if I talk about the nominal shear stress can be written as tau V is equal to Vu upon B into D. So what is tau V, sir? Tau V can be written as Vu upon BD, where Vu is the shear force and B and D are the dimensions of the section. Now similarly, see students, this formula tau V is equal to V upon BD, this is for uniform section. Sir, this is for which section? This is for uniform section. And remember, my dear students, here tau V can be written as Vu plus or minus M by D into tan beta. This is the formula for nominal shear stress for varying section. Now see students, when do you use positive sign and when do you use negative sign, I will tell you. Suppose if you consider a cantilever beam, here see students, usually in cantilever beam, the maximum bending moment will be at fixed end. See, as the depth is increasing, the moment is also increasing. In that case, you will use negative sign. In this case, you will use negative sign. But if I consider a simply supported beam here, students, if I consider a simply supported beam here, like this, you see, usually the bending moment diagram will be like this, and here the bending moment diagram will be like this. Now see, the bending moment is maximum at the ends. As the depth is increasing, moment is decreasing in this case. So you will be using positive sign here. So this is a very important question, Amma. They have asked you in the previous gate question also. So in the design steps, first we have taken nominal shear stress is tau V is equal to Vu upon BD. And if you talk about varying section, it is given as Vu plus or minus M by D into tan beta, where beta is the angle here, where beta is this angle. Okay. Now see students, here remember you have when to use positive and when to use negative. Okay. Cantilever negative, simply supported positive, so that you can get a better understanding. Next, see students, tau C is known as permissible shear stress. Tau C is known as permissible shear stress. Okay, tau V is known as nominal shear stress. Okay, now my dear students, see, here tau V less than 0.5 tau C, this is a very important point. When tau V is less than 0.5 tau C, you should remember that there is no requirement of shear. Okay, shear means you will provide in the form of stirrups, bent up bars, inclined bars and all. So when tau V is less than 0.5 tau C, 0.5 tau C, no shear reinforcement. Suppose if tau V is less than tau C, you should provide minimum shear reinforcement. What, sir? If tau V is less than tau C, what you have to do? You have to provide the minimum shear reinforcement is provided, you can write. Now what is the formula for minimum reinforcement is ASV. What is ASV means? Area of the shear reinforcement or area of stirrups. A into area of the stirrups is A into BSV is equal to 0.4 upon 0.87 F5. So this is the formula for minimum shear reinforcement. Now see students, usually when tau V is greater than tau C, when tau V is greater than tau C, shear reinforcement is mandatory. What, sir? When tau V is greater than tau C, shear reinforcement is mandatory. I told you already students, shear reinforcement is provided in the form of inclined bars, bent up bars. Okay. Now how do you provide shear reinforcement? See, how do you calculate design shear force? Here is design shear force is given by the formula tau V minus tau C into B into D. How do you calculate design shear force, students? Design shear force is given by the formula tau V minus tau C into B into D is the design shear force. Okay. Similarly, see students, we have calculated the design shear force. Now, how do you calculate design shear force? In the other way, I will tell you. Sir, see, there is other way also, design shear force, that is 0.87 into Fy into ASV. So, this is the stress into area, but into D upon SV. Here, D upon SV represents the number of stirrups. How? I will tell you, student. This is also important, actually. If we consider this as the reinforcement, students, we have the stirrups like this, right? Now, if I consider the length of the crack, if I consider this as the length of the crack as L, if I consider the length of the crack as L, if the spacing between the stirrups, if I take it as SV, so what will be the number of stirrups means? Usually the length of the crack will be taken as D, sir. What is L? L is nothing but the length of the crack, and practically the length of the crack will be equal to D. So this is the formula for design shear force, where you can use the formula in case of spacings. And remember students, last point, spacing cannot be more than, vertical spacing cannot be more than 300 mm or it cannot be more than 0.75 D. Remember, if you can follow these steps, you can solve any problem in the shear concept. Now please solve this question, students. I will give you 2 minutes of time. I will give you 2 minutes of time. Please solve that problem. I have given you enough time, Amma. The question here is a pre-tension rectangular beam of 150 mm wide and 300 depth is pre-stressed with 3 straight tendons having a cross-sectional area of initial stress 1200 Newton per mm square. The tendons are located at 100 mm from the soffit. Soffit means from the bottom of the beam. If the modular ratio is 6, the loss of pre-stressing force due to elastic deformation. Now please see students what he has asked in the problem. Let me tell you what he has asked in the problem. Sir, he is not asking pre-stress, he is asking loss of pre-stressing force. So first we will calculate loss of pre-stress. So what is the loss of pre-stress due to elastic shortening of concrete? Do you remember students, the loss of pre-stress due to elastic shortening is given by the formula how much, sir? What is the formula for elastic loss due to loss of pre-stress due to elastic shortening is given by the formula M into FC, right? Where M indicates, here see students, here M indicates the modular ratio, here M indicates the modular ratio, here M indicates the modular ratio, FC is nothing but the stress at the level of steel. What is FC, sir? FC is nothing but the stress at the level of steel. Agree or not, students? Now when I talk about here, what is FC here? FC can be written as load by area plus PE square upon I. Now see students, if I consider here, what is the section width, sir? This is 150 mm width. He has given in the problem, it has 150 mm width and 300 mm deep. Okay. So what is this width? So this is 150 mm. So this is 150 mm and we have steel bars which are placed at bottom. These are placed from bottom, which is equal to how much, sir? From bottom they are placed at 100 mm. So what will be the eccentricity first? Eccentricity will be equal to 150, that is equal to 150 minus 100. How do you got 150, sir? Overall depth upon 2. Okay, so this eccentricity value will be equal to 50 mm. Now, what is the stress? How to calculate the pre-stressing force? Sir, what is P here? P is nothing but the pre-stressing force. So, see students, P is nothing but the what, sir? P is nothing but the pre-stressing force. So, how to calculate the pre-stressing force? You can write it as stress into area of steel. So here what is the area of steel, sir? There are 3 tendons. Okay, the tendons are located at 100 mm and there are 3 tendons which are of 50 mm square. So let me draw here. Are you following, students? Very good. Now the pre-stressing force P is nothing but what, sir? P is nothing but the pre-stressing force. Here P is nothing but the pre-stressing force. Here what is pre-stressing force, students? Pre-stressing force is nothing but sigma into AST. What is sigma, sir? Sigma is nothing but 1200 Newton per mm square into 3 bars into 50. So here if you see here, you can say pre-stressing force is equal to 180 kilonewton, or you can say 180 into 10 power 3. Now see students, if you talk about the FC, stress at the level of steel. Okay, FC can be written as what, sir? Load upon area plus PE square into I. Right? Let me try this. Now, if I take here load, what is load, sir? 180 into 10 power 3. And what is area, students? Area is nothing but section which is of width 150 and depth 300 plus PE square. PE is how much, sir? 180 into 10 power 3. And what is E, sir? E is nothing but 50 square upon what is the I? What is the moment of inertia for rectangular section? It is nothing but BD cube by 12. So 150 into 300 BD cube by 12. 300 cube by 12. So here, if I do here 50, 50, so 12 will go. If you solve this, what is the stress value you will get, sir? You will get this value if you solve this summa. So it is 45, you will get 4. 4 plus 4 by 3, you will get a value of 5.33 Newton per mm square. So what is the stress value you will get? 5.33 Newton per mm square. Now let me tell you what is the loss of pre-stress, sir. What is the loss of pre-stress here? What is the loss of pre-stress, students? The loss of pre-stress due to elastic shortening is given by the formula M into FC. So M value is how much, sir? 6. 6 into 4 plus 4 by 3. You got how much, sir? 5.33, right? 5.33. So if you see here, you will get 32 MPa. But what he has asked in the problem, again I am telling you, students, he has asked in the problem what is the loss of pre-stress force. He has problem what is the loss of pre-stressing force. So pre-stressing force means after finding the stress, so you can write loss of pre-stressing force is equal to loss of pre-stress due to elastic shortening into area of steel. So this will be equal to 32 MPa into 3 into 50. If you see, you will get around 4,800 Newton per mm, Newton. 4,800 Newton, which you can write it as 4.8 kilonewton. So remember again and again, my dear students, here what I would like to tell you is, when they ask you force, you should not calculate stress. You should multiply the stress with the area of steel, which you will calculate the pre-stressing force. So remember again, students, the loss of pre-stress due to elastic shortening is given by the formula M into FC, where M indicates the modular ratio. FC is nothing but the stress at the level of steel. The word level of steel has a lot of meaning, because when you take the section modulus, it is I upon Y. If you take Y bar at the extreme fiber, the values will change. That is the reason I am stressing. This is the key point for this problem. So let us go to the next problem. Please solve this problem, students. I'll give you 1-2 minutes of time. Now see, students, I have given you enough time. Actually, see here, the question here is, a simply supported rectangular beam has a 8-meter span is to be pre-stressed with a force of 1600 kilonewton. The tendon of the parabolic is the tendon is of parabolic profile, having zero eccentricity at the support. The beam has carrying a uniformly external load of intensity 30 kilonewton per meter. Neglect the self weight of the beam. What is the maximum dip is asking. Now see, students, actually we have a concept called load balancing effect. Load balancing effect. When I talk about the load balancing effect, students, what I would like to tell you here is, if you consider this as a span, okay, you will have a UDL, and due to this UDL, if you consider the tendon here, means you have a tendon, the profile of the tendon is parabola, and you might have some load here, right? So what you can see is the the due to UDL, if you assume that the profile of the tendon is UDL, so moment due to self weight, moment due to self weight can be taken as what, sir? Which is a parabola, means it is a UDL loading, WL square by 8. And now see, sir, we have a tendon and this is neutral axis. We have a pre-stressing force, right? So pre-stressing force, the whatever the moment which is causing due to the UDL or live load or dead load has to be balanced by the pre-stressing moment. So here this will be equal to pre-stressing force into eccentricity. So here eccentricity is nothing but what, sir? Dip. So how do you calculate? E can be written as WL square upon 8P. Now my dear students, here see, where W is given as how much, sir? 30 into 8 square. Are you getting me, sir? 30 into 8 square. 30 is the kilonewton per meter. And what is P they have given? P is given as 1600 kilonewton. So P is equal to 8 into 1600 kilonewton. Okay, sir. If you solve these, students, 8 cancel, 8 into 8 by 200. So 3 by 20. So 1.5. You will get E value as 0.15 meter. That is equal to, if they ask you what is the value, maximum dip in mm, the value here is how much, students? It is equal to 150 mm. So here we are using the load balancing concept, students. Whatever the movement which is caused due to the dead load or live load is balanced by the pre-stressing force with an eccentricity E. So by using those two concepts, we are calculating the maximum dip value. I hope you have understand this solution. With this, we are done with the solutions part, students. Students, if you want to have the classroom notes which we have discussed in the YouTube, or if you are looking for a daily quizzes, and if you want to test yourself, or whatever the activities which are happening in the IMS Gate Academy YouTube channel, definitely you will get all the updates in this Telegram group mentioned in the description. Just click on the link and join the group. It would be really helpful for the students who want to quickly revise the most conceptual problems and also to get access the free programs which are conducted in the YouTube. Apart from this, students, I would like to tell you, we at IMS Gate Academy proudly say that we are offering 800 plus hours of gate coaching for both online and offline, and we are providing the gate coaching for all the 6 streams in the engineering, and we provide for everywhere, wherever you go, practice makes always perfect. So for this, we are providing excellent study material. We are providing you the subject wise test books. Apart from that, we are also providing the exercise books where it contains level 1, level 2, level 3 questions. And the beauty of the questions, where it covers multiple select questions, multiple choice questions, and fill in the blank question. And based on the preparation of your level, you can go with level 1, level 2 and level 3 questions based on your choice. And the next important thing, students, we are offering 30 plus years of gate, all the previous year gate questions with solid solutions. Apart from that, we are also providing key pointers for each and every previous year gate solution, and we are also giving some recorded solutions of the previous year questions. Apart from that, see, students, everywhere you have to test yourself, and in testing yourself, we at IMS Gate Academy proudly say that we are offering 130 plus test series which include chapter wise tests, subject wise tests, multiple subject tests, advanced level tests, and also it includes the most important theory, that is All India mock test series, which consists of 12. The exact means it is the kind of same environment how you will be attempting the exam in the gate real-time gate exam. Apart from this, we at IMS Gate Academy have achieved the success with one-to-one mentorship, which is very important to understand the student's strength and weakness. Apart from that, we are also offering the doubt solving portal, where when you post a doubt, that doubt can be answered within 24 hours of time. I hope this session will keep you understanding the concepts of RCC. Still, if you have any queries, definitely you can join in the Telegram group and I will update you 100%. Sir, when will be the next session and what will be the subject? Nikhil, my next session will be on 26th, hydrology. I have completed already transportation, environmental. If you talk about transportation, environmental, sorry, I have completed transportation, geotechnical, survey and RCC. They are available in the playlist. You can go through those sessions. And in the coming session, Pratik sir might be taking, he will be handling environmental. I am not aware the subjects which we will be handling structure analysis or environmental engineering. So stay tuned for this YouTube channel, Nikhil. If you want to have any updates, you can join in the Telegram group, and all the updates will be shared in the Telegram. Thank you and all the best for your GATE exam, my dear students. Remember students, it is the time for you to realize and get practice to the GATE 23 exam. And most importantly, if you are attempting the multiple select question, I am again and again telling you students, you have to have a thorough knowledge on the conceptuals. Once you are very much thorough with the concept only, then only you can attempt the multiple select question. Thank you, Nikhil. With this, I am ending the session. Thank you, one and all.